Look at the light on your hand. No, really. Hold your hand up for a moment and look at it. If you're indoors, that light may have come from a bulb across the room. If you're outside, maybe some of it came from the sun. And if it came from the sun, then somewhere in the back of your mind you've got this little fact stored away from school. Sunlight takes about 8 minutes and 20 seconds to reach the Earth. That sounds simple, harmless, ordinary, and yet buried inside that ordinary statement is one of the strangest things we know about reality. Because the moment you ask a very innocent question, 8 minutes according to whose clock, the whole picture begins to shift. That's the thing I always liked about physics. The obvious things, the things people think are too obvious to examine, are often the ones with the deepest machinery hiding underneath. The light took 8 minutes to get here. Sounds like one of those simple facts you put in a textbook and move on. But if you start pulling on that thread, it drags out relativity, the structure of spacetime, the meaning of distance, the failure of universal simultaneity, and eventually the unsettling realization that your common sense picture of time is not the way nature works. So let's slow down and look carefully. When we say sunlight takes about 8 minutes to reach Earth, that is true, but it is true from our frame, using our clocks, sitting here on a planet moving relatively slowly compared with the speed of light. It is a perfectly good statement in the Earth-Sun frame. If you want to predict when dawn arrives, or how long it takes a solar flare to affect satellites, it's exactly the right statement. But now suppose you ask a different question. What is the elapsed proper time along the path of the light itself? Now we are entering stranger territory. For material objects, people, clocks, spaceships, proper time is the time measured along their world line. That's the time your wristwatch experiences. But light does not behave like an ordinary object with a valid rest frame. A photon has no mass, and because of that, in special relativity, you cannot define an ordinary inertial rest frame for it. So one has to be careful. When people say, from the photon's perspective, the trip took 0 time, they are saying something suggestive, but a little sloppy. A photon does not literally have a normal perspective the way you do in a chair or an astronaut does in a rocket. Still, the mathematics points towards something extraordinary. The space-time interval along a light-like path corresponds to 0 proper time. That is not poetry, that is the geometry. So while we, with our clocks and our mass and our slow-moving bodies, say the sunlight took 8 minutes to get here, the light itself does not age through that journey in the ordinary sense. It does not accumulate proper time the way a material traveler would. That is already enough to disturb your intuition, because intuition wants to imagine everything as a little object moving through a giant cosmic hallway. But light is not like that. Light is one of the things that forces you to stop thinking like a primate and start thinking like a relativist. Now let's step back and look at the most famous number in physics, 299,792,458 meters per second, the speed of light. People memorize that number in school and usually think of it as a kind of cosmic speed limit sign. Nothing goes faster because nature doesn't allow speeding tickets above that number. That's not completely wrong, but it isn't the deepest way to understand it. That number is not merely about light. Light is important because it reveals the number very clearly, but the number itself is more fundamental than light. It appears in Maxwell's equations before Einstein ever reinterpreted it. It is the conversion factor between space and time in relativity. It is the invariant speed built into the structure of space-time itself. If you like, it is the speed at which causal influences carried by massless fields propagate. It is part of the geometry of the universe. Calling it merely the speed of light is a little like calling the speed of sound the speed of beeps. It's not false exactly, but it misses the deeper point. Why does this matter? Because in ordinary life you think of speed as motion through space. A baseball travels through air. A train travels along a track. A planet goes around a star. You imagine there is space, and then there are things moving through it. Einstein forces a more subtle view. Space and time are not separate stages on which matter performs. They are aspects of a single structure, space-time. And once you see that, you can start using a picture that is not exact in every technical detail but is useful for intuition. You can imagine that everything is always moving through space-time, and what changes is how that motion is divided between motion through space and motion through time. When you are sitting still in a chair relative to the room, almost all of your motion in this loose picture is through time. Your clock ticks normally, 1 second per second, so to speak. But if you begin moving rapidly through space, your motion through time changes. Your clock runs more slowly relative to someone at rest. That is not a visual illusion. That is not just light taking longer to reach the observer. Once you correct for signal delays, the moving clock really does tick slower. Time dilation is real. It has been measured endlessly. Muons in the atmosphere live longer than classical reasoning would suggest because from our frame their internal clocks are slow. Particle accelerators rely on it. GPS satellites must correct for relativity, or your map would wander badly. So this is not philosophy stapled onto physics. This is engineering. Now imagine a clock floating in space. Give it a nice ordinary face, a second hand ticking around in a comforting way. If it drifts slowly past you, it looks normal, but accelerate it to a significant fraction of the speed of light, and the clock slows relative to you. Push it harder, 50% of light speed, 90%, 99%, and the slowdown becomes dramatic. At 99%, the effect is enormous. At 99.9%, it is astonishing. At 99.99%, from your point of view, the moving clock barely advances while your own time flows on. This is the kind of thing that should permanently cure anyone of trusting raw intuition in relativistic situations. And now naturally one asks, what happens in the limit? If you had a spaceship that could get closer and closer to the speed of light, its time dilation would become larger and larger. A journey that looked like many years from Earth could be much shorter for the traveler. That's the basis of the twin paradox. One twin leaves at high speed, turns around, comes home younger, not because of a trick, but because different world lines through space-time accumulate different amounts of proper time. People love that story, but they usually stop it before the strangest part. They say, look, the fast-moving twin aged less. Fine. But then the mind asks, what if we keep going? What if we approach light speed itself? And this is where one must be both bold and careful. For a massive object, you never actually get there. The required energy blows up. You can approach the speed of light, but not reach it. So there is no physical spaceship whose clock we can follow all the way to sea. But light itself does move at sea. And light follows light like paths for which the proper time is zero. That is the mathematically correct statement. It means the ordinary way we think about a journey, a traveler leaving one place, experiencing duration, and arriving later, does not apply in the same way to light. So when a photon leaves the sun and later strikes your eye, we say it took 8 minutes because that is what our clocks on Earth measure. But if you ask for the proper time along the light's path, the answer is 0. Now I want you to pause with that, because this is where most people's brains start trying to protect them by converting the idea into mush. They say, so for the photon, the trip is instantaneous. That's not bad as an intuition, provided you remember it is shorthand. The careful version is that a photon does not have a standard rest frame, but the proper time along its trajectory is 0. If you forget that caution, you start saying things that sound deep but are just sloppy. And Feynman's style, if I learned anything from it, is that honesty matters more than drama. The truth is already dramatic enough. Now let us push further, because the consequences are fascinating. Suppose you look at a star 4 billion light years away. You say quite correctly in astronomy, I am seeing light that left that star 4 billion years ago. Yes. By our cosmological clocks, by our frame, by the time coordinate appropriate to our description, that is exactly what you are seeing. But the light itself did not live through 4 billion years the way a person would live through 4 billion years. It does not carry an internal wristwatch that ticked for 4 billion years. So the light is ancient in one perfectly legitimate sense. It was emitted a long time ago in our frame, but not ancient in the everyday experiential sense. That should make you uneasy in a productive way, because it tells you that age is not a simple universal label you can attach to every entity in the same manner. Now we come to the idea that really unsettles people, the relativity of simultaneity. You and I standing side by side can agree fairly easily on what now means in our local surroundings. We synchronize watches, we point to a passing car, we say it happened now. Fine. But if I board a spaceship and move away at high speed relative to you, then the set of distant events I consider simultaneous with my present is not the same set you consider simultaneous with your present. There is no universal cosmic now. That is one of the deepest lessons of relativity. People want there to be a God's eye slice through the universe labeled present with everyone agreeing on it. Nature does not provide one. Different observers in relative motion slice space-time differently. What counts as now for one can include events in other places in the past or future. This is not science fiction, it is built into Lorentz transformations. And once you accept that, the old picture of the universe as a universal moving present, dragging the future into existence and shedding the past behind it, begins to look less like physics and more like a deeply rooted psychological habit. That is why some physicists and philosophers like the block universe picture. In that picture, space-time is not a thing that is happening all at once in the ordinary sense. Rather, the whole four-dimensional structure exists, and what we call past, present, and future are different regions of that structure. We experience a local, moving present because of the way conscious systems like us process information along our world lines. But there is no universal present sweeping the cosmos. Now I should say something honest again. The block universe is a way of interpreting relativity, and many people find it compelling. But one must not confuse a useful geometric interpretation with the one final metaphysical truth. Physics gives you the structure, interpretation comes afterward. Still, the structure strongly undermines naive presentism, the idea that only the present is real. So when you say the star exploded in the past, that is meaningful in your frame, in your description. But relativity warns you not to turn that into a universal metaphysical decree.
Now what about the Big Bang? This is where scripts often become dramatic in a scientifically dangerous way. They say, if light doesn't experience time, then the Big Bang is happening right now. That sounds thrilling, but it is too careless. The universe's age, about 13.8 billion years, is not a fake number. It is not an illusion in the cheap sense. It is defined using cosmic time, the time measured by co-moving observers moving with the large-scale expansion of the universe. In that framework, the age of the universe is perfectly meaningful and enormously useful. Cosmology is not broken because relativity is subtle. Quite the opposite. Cosmology works because relativity is precise. But photons from the early universe, such as the cosmic microwave background, travel on null paths and do not accumulate proper time like matter does. So if you ask, how old is a CMB photon in terms of the universe's cosmic time, you get one answer. If you ask, how much proper time elapsed along its trajectory, you get another, namely 0. Both are true in their proper context. That is the kind of thing physics forces you to learn. Not that time is fake, but that there are different, frame-dependent and path-dependent notions of temporal interval, and common sense is too crude to handle them without help. So no, we should not say the universe is not 13.8 billion years old. We should say something more interesting. Our ordinary intuitive notion of time is not the final story, and light reveals this with unusual clarity. Now let us talk about space. Relativity does not only alter time intervals, it alters distances too. If an object moves rapidly relative to you, lengths along the direction of motion are contracted in its frame. At 99% of the speed of light, this contraction becomes substantial. At 99.999%, dramatic. Again, not an optical illusion in the cheap sense, but a real feature of how space-time geometry is measured in different frames. So people like to say, for light, distance contracts to 0. And again, that is a dangerous half-truth. Since light has no rest frame, you must not speak too literally, as though the photon were carrying around a ruler and observing a shrunken universe. But as a limiting intuition, the closer you push a massive observer toward C, the more the traverse distance in that direction contracts in the observer's frame, and the less proper time the journey takes. That is why high-speed interstellar travel is possible in principle for the traveler without requiring absurd personal durations, though of course the outside universe ages enormously while the traveler does it. But light itself is not a traveler in the ordinary sense. It is something stranger, a massless excitation following a null path. This is why light resists all our ordinary language. It is not a little bullet with a tiny watch. It is not a commuter commuting. And that is what makes it so philosophically disruptive. Now let me get to the emotional center of all this. What are we then? Why do we experience time so strongly if the underlying structure of the universe is so much subtler than our experience suggests? Because we have mass. Because we are made of matter. Because our brains are information processing systems that build memories in one temporal direction, track change, compare states, and live within thermodynamic arrows. We are not photons, we are warm, messy biological systems. We metabolize, we age, we store records, we carry histories in our bodies. We build clocks out of oscillations and cycles, and then mistake those clocks for the ultimate architecture of reality. That is very human. We do not create time in the literal sense, of course. That would be too strong. But we do create the psychological experience of flowing time by being the sort of creatures we are, creatures embedded in entropy gradients, creatures who remember lower entropy past states and not higher entropy future ones, creatures whose bodies change in ordered ways we call aging. So maybe the deepest truth is not that time is a hallucination. It is that our everyday experience of time is a local, thermodynamic, matter-bound way of slicing something much richer. That, to me, is more interesting than saying time is fake. Now imagine for one final moment that you are looking at a star tonight. The light from that star enters your eye. In one perfectly legitimate astronomical sense, that light has been traveling for years, or centuries, or millions of years. In another relativistic sense, the path it followed is light-like and accumulates no proper time. That means the universe is giving you two descriptions at once. One says the light comes from the past. The other says the structure of space-time does not permit you to think of that journey in the ordinary traveler's way. That tension is not a flaw, it is the beauty.
You and the star are not the same place in any ordinary sense, and yet you are connected by a null path in the geometry of space-time. A process in a distant star altered the electromagnetic field, and now, after an interval defined in your frame, that alteration has become part of your present experience. That is astonishing enough. We do not need to exaggerate it into bad philosophy. The good physics is already more beautiful than the exaggeration. So no, light is not literally older than the universe. No, the universe is not simply a lie because cosmology uses time. No, photons do not have a proper rest frame from which to watch the Big Bang and the end of the universe touching. But yes, light shows us that our ordinary ideas of time, age, distance, and simultaneity are provincial. They belong to the slow world of matter, the world of people and clocks and planets and memory. Light lives on the edge of that structure and reveals how strange the structure really is. And maybe that is the real lesson, not that reality is mystical, not that time is unreal, but that the universe is subtler than the stories our nervous systems evolved to tell. So when you look at the light on your hand, you are not merely seeing something that traveled from there to here. You are seeing relativity made visible. You are seeing the geometry of space-time written in sunlight. You are seeing that the distinction between a journey and an instant depends on the path, the frame, and the kind of thing you are asking about. And if that doesn't make you stop for a second and smile, I don't know what will. Because the universe, once you really let it speak in its own language, is far stranger than fantasy and far more precise. So go outside tonight, look up, find a star, and remember the light reaching your eye is not just old, it is teaching you how little your intuition knew about time. And that is one of the nicest gifts physics can give.